Hello everyone, especially Dr. Loads. Let me widen my screen here a bit. Alright, we're going to be using Geogebra to explore some reflections and rotations real quick here. I'm going to create a polygon. I've got the grid turned on so it's nice and easy to see what I am doing. Now we have a triangle. I am going to reflect this triangle twice, and then I'm going to attempt to use a rotation and show that two reflections does indeed equal a rotation. So I'm going to reflect it about this line. Let me first create a line. There's one line. And I will reflect this about that line. There it is over there. See how it goes 1 point over here, 1 point over there. 1, 2, 3 points. 1, 2, 3 points. 1, 2, 3. 1, 2, 3. So it's a perfect reflection. And now, let's see. I will create another line right here. And I will reflect this about this line. So now we're down here. Alright, this one should be fairly simple for me to just show that I can rotate this over to this position here. I'm going to go ahead and pick rotate about a point right here. Now I need to pick a point. And let me see. This is at 1, 2. And this is at 7, 0. So there's 1, 2, 3 in between and 1 up. I'll use this point right there. Oops. I have a line in my way. I'm going to try to hide that line. Oh, hello. Wow, look at that. I can move this thing back and forth as the line of reflection gets moved. I can just grab it and move. That's nifty. Does not, however, help me in hiding things. Alright, we will go ahead and just rotate about a different point. Rotate about a point. Rotate about a point. I'm going to create a point close, but not quite to on that section since it won't let me do it. There we go. It let me do it. Good. Alright, now I want to rotate this about this point. Come on, rotate. And I would like to rotate it first. Let's go 90 degrees. So I'll hit OK. Great. Now it's over here. So this came down here. The angle between these is a 90-degree alpha. So now I'm going to rotate it again. 90 degrees. And ta-da! It appeared exactly where I was expecting it to appear, given the center point. So, two reflections equals a 180-degree rotation in this instance. Let's see, what other fun things can I do here? I could do a translation. Translation is pretty simple. Let me see here. Grab this. Oh, that's this entire thing here. Okay. Move, move, move. And as I stretch this out here, notice this comes out 1, this goes out 1, and all of this goes out 1 here and down 1 here. So the reflection and the rotation stay consistent all the way around. Now what I'm doing, in essence, what I just did is I translated this entire triangle from here over 1. I moved this point to the left 1, I moved this point to the left 1, and I moved this point to the left 1. So that would be a translation. And let's see. Anything else I want to do in this video? Translate by vector. I'm going to take this and I'll translate it like that. So do this and translate it by that much vector, and look, I moved it 2 spaces down this direction on my vector. Indeed, this point moved 2, this point moved 2, and this point moved 2. So I can translate it that way as well. Now I'll create an opposite vector. I want to undo that. Undo. And undo once more. Alright. There. Now, here's my new vector. I'm going to take this object and translate it by this vector, and it should appear, boom, right back where it was. So now this vector and this vector cancel each other out. Incidentally, this translation plus this translation is the identity translation. Alright, I think that's enough for this video. I'm going to go ahead and hit stop, and if I can think of anything else, I'll add it in later.